this video, I'm going to discuss how to find confidence intervals for the population mean when you have a small sample size. So small sample size, that means maybe n less than or equal to 30. That's a basic rule of thumb. It's not exact, right? But when you have a relatively small sample size, and standard deviation, sigma, is not known. So remember, sigma is the population standard deviation. So we don't know the population standard deviation. But we do have a sample, so we do know the sample standard deviation, okay? And I'm going to be using Excel as my calculator. Let's go ahead and read through an example. Below, we have the 1.5 mile run times for 10 randomly selected sailors. Assume the run times are normally distributed, okay? When you have a small sample size, you're going to need this assumption. If you don't have this assumption, then you kind of can't use the formulas that I'm about to be discussing. You can't use the methods I'm using here. You have to use different methods to construct your confidence interval. Okay, but we do have this assumption. So now we need to find the 95% confidence interval for the average runtime of these sailors. Okay, so remember, what is a confidence interval? You have your sample mean in the middle, and then you go down and you go up, and you figure out some number below the sample mean and some number above the sample mean, and you basically construct an interval based off of those two numbers, right? So how far below and how far above the sample mean do you go? Well, you go E in both directions, right? E is the margin of error. And when you had a large sample size, the formula for E looked like this, with E equals Z sigma over the square root of n, okay? And Z might have the subscript alpha over 2, or it might have the subscript C. Don't get caught up with that. They're the same thing. All right, this is for large sample size, so n greater than 30, okay? Right now, what is n? N is just 10. I only have 10 sailors, so I can't use that one right now. I'll need to use this new formula that has T, okay, and S. Instead of having this sigma, it has S. Okay, what's the difference? Remember, this is for a sample. This is the sample standard deviation, and this is the population standard deviation. Okay, so basically, when you have a small sample size, so n less than or equal to 30, you can no longer make that assumption where before we were saying, you know what, we calculated S and it's close enough to sigma, so we just went ahead and used this formula, right? You can't do that when you have a small sample size, so n less than 30, okay? So you're going to need to use this formula. All right, so this is the formula for us for right now. This is what we're going to use. All right, and I know you might be thinking, oh gosh, there's another T. I just started maybe getting used to what Z was, and now I have this T guy. What am I going to do about that? Well, don't worry about it. Excel actually will take care of it for us, okay? So don't worry too much about it being a different distribution than Z. It looks very similar to the normal distribution. The distribution of T, the only difference is that the tails are a little wider, okay? And it is an important difference in terms of your calculation, but the way it looks and the way we will work with it, it's very similar to the way we worked with the normal distribution, okay? All right, so I need to calculate this margin of error. First thing, let me go ahead and put all of my data in Excel. Okay, so I've done that. Just copied and pasted it in here. And the first thing I'm going to want to know is, what is X bar, right? What is the sample mean? Okay, let me make that a little smaller. So sample mean. So to calculate the sample mean, or X bar, pick a cell, type in equals, average, open parentheses, highlight your data. Okay, so just click and drag, close parentheses, and press enter. There we go. Next, I need to know what is S, or the sample standard deviation. Type in equals STDEV dot S. Double click on it. So you might have noticed that there was also a dot P and a dot S below it. P is for the population and S is for sample. Okay, so since we have a sample, we'll want that one. Highlight your data, click and drag, close parentheses, and press enter. All right, great. So now I need to know what is E. What is the margin of error? Okay, Excel will calculate this for me. I'll type in equals confidence. All right, you see how there's confidence.norm and confidence.t? Well, we're doing t now. Norm was basically the z when we had a large sample size. And when we have a small sample size, we'll need to use t. All right, alpha. What is alpha? Okay, let me go back to my problem. What is alpha? Alpha depends on your confidence interval. So right now, if I were to draw out the distribution of t, okay, and it's centered on 0, we are constructing a 95% confidence interval. So because it's a 95% confidence interval, 0.95 is in the middle of the distribution of t, okay? So what is alpha? Alpha is how much is left over. So 1 minus 0.95 equals 0.05, okay? So there's 0.05 left over for the tails, okay? How much does each tail have? All right, because this is a symmetric distribution, basically half of it needs to be on the left and half of it needs to be on the right. So we would need to take 0.05 and divide it by 2, and we would find that 0.025 is on the right and 0.025 is on the left. Okay, really I didn't need to do that calculation though, because really all Excel is asking me is what is alpha. And alpha is just always going to be 1 minus whatever your confidence level is. Okay, so 0.05. Let me go back to Excel. So alpha is 0.05. The standard deviation, okay, I could type it in, but I could also just click on that cell. That's easy. That'll plug it in for me. And then size. Size is the number of data points that you have, or n, right? So we have 10. Okay, close parentheses and press enter. Great, there's our margin of error, 0.99, if I were to round that, 0.995. So we calculated E equals 0.995. Okay, and also Excel found the sample mean to be 10.351. All right, so let me go ahead and write that down. So the sample mean was 10.351, and we want to travel below and above the sample mean by 0.995. 0.995. Okay, so I just basically need to add 0.995 to the mean and subtract it from the mean. Okay, so let me write this down. I'll start with the lower limit. The lower limit will be equal to the sample mean minus the margin of error. Okay, and the upper limit will be type in equals the sample mean plus the margin of error. Press enter. So there we go. 9.356 and 11.346. All right, so what's my answer? What is my confidence interval? My confidence interval is just basically these two numbers. So we are 95% confident that the population mean is between 9.356 minutes and 11.346 minutes. All right, and you could just be done with the video here, right? But actually, I do want to talk about another way you could have done this if you wanted to actually use this formula and figure out each piece of the formula. So like, how do I figure out what T is? How do I figure, well, we know what S is and we know what N are, but basically, how do I figure out what T is directly? Well, Excel can calculate it directly for me, but before I go to Excel, let's talk about it for a second. So this guy, T alpha divided by 2, is basically this cutoff in this distribution. Okay, so T alpha divided by 2 is here, and T alpha divided by 2 is here. This one is less than 0 because you're to the left of 0. So this one is negative, and this one is positive. Okay, so I'm going to actually find the negative one. Your formula is always positive, so I'll just change the sign. So in Excel, what I'm going to need to tell Excel is I want to know what's the T value when the probability of being less than that value is this probability that we already calculated here, 0.025. Do you remember how we calculated that? We found the area that's left over, right? This total area left over is 0.05, and then needs to be equally split in the two tails, so it's 0.025 in each tail. Okay, so let's go to Excel. And right now I want to calculate T subscript C or T alpha divided by 2, either way, same thing. So equals T dot inverse, open parentheses, and give it that probability, 0.025. It has one more thing it needs though, right? It doesn't just need the probability, it also needs the degrees of freedom. So what is degrees of freedom? Degrees of freedom is the sample size minus 1. Okay, so let me write that down so we don't forget it. The degrees of freedom of this distribution is n minus 1, which right now it's 10 minus 1, which is 9. Where did I get 10 from? Because we have 10 observations. Our data has the data for 10 randomly selected sailors. Okay, so 10 minus 1, the degrees of freedom is 9. The degrees of freedom is 9. Okay, so type in 9, close parentheses, and press enter. Negative 2.26, right? We'll just round to 2 decimal places. Negative 2.26. So like I said, this guy's negative, the guy that we just calculated, it was negative 2.26. So the positive version is just positive 2.26, right? So if I wanted to calculate E, I would plug in 2.26 for T, okay? S, the standard deviation, right? What was our sample standard deviation? 1.39. So I would say times 1.39 divided by the square root of 10. The sample size is 10. Okay? Now you can plug this into a calculator, or you could plug it into Excel. Remember, Excel basically is a calculator. And plug this in. So I have E. I'm again calculating the margin of error. And let's see. I have 2.26 times 1.39 divided by SQRT, that's the square root function, of 10. Okay? And then press enter. All right, notice that it is slightly different than the number that we already calculated, right? So this number and this number are different. Why is that? Well, it's due to rounding error. So if I were to do exact values, you notice I rounded both the standard deviation and the t value, and that's why I got the slightly different number. So if I were to not round, so let me, instead of rounding this, let me delete it, and let me press this value. Okay, I want to change the sign, so make it negative. And instead of rounding the standard deviation, let me delete it and do the exact standard deviation value by pressing on that cell there. And then press enter, and there you go. They're exactly the same. Okay, so they are the same. You're going to have rounding error if you round, so you need to be mindful of that. Using Excel as your calculator is a great way to avoid those type of errors. All right, and then once you have the margin of error, then basically you do the exact same thing to find the upper and lower limits. And you will arrive at the same answer for your confidence interval.